So the question is, the acceleration of a cart started at t is equal to 0 varies with time as shown in the figure. Find the distance traveled in 30 seconds and draw the position time graph. So this is an acceleration time graph. Here acceleration is in feet per second square. Okay, we have to find the distance traveled in 30 seconds. So first we consider the first 10 seconds. Okay, so in the first 10 seconds, we know that the cart start from rest. That is, the initial velocity is 0. What's the acceleration in the first 10 seconds? Is acceleration is 5. So what's the time? Time is 10. So the distance traveled equals s is equal to ut plus half a t square. So u is equal to 0, that is half into a 5 into t square, that is 100. So equals 250 feet. So that's the distance traveled in the first 10 seconds. Okay, so it starts from rest. What's the velocity of the cart at end of 10 seconds? So we know that velocity equals u plus at. So initial velocity equals 0. Acceleration is 5. Time 10. So the velocity at 10 seconds equals 50 feet per second. So we found out that the distance traveled in first 10 seconds is 250. Now the second part, that is from 10 seconds to 20 seconds. Here acceleration equals 0. There is no acceleration. So if there is no acceleration, distance traveled equals velocity into time. So what's the velocity at the end of 10 seconds? 50. Okay, so it will not change because there is no acceleration. So distance traveled equals 50 into time 10 seconds. That is 500 feet. Okay, so the distance covered from during 10 to 20 seconds equals 50 feet. Now again from 20 to 30 seconds. So we have to find the distance travel from 20 to 30 seconds. So what's the initial velocity there? U is 50. Okay, it will not change because the initial velocity is 50. Acceleration minus 5. Okay, minus 5. Time 10. S equals ut plus half at square. Okay, so ut means u is equal to 550. So ut t 10 minus half a 5 t square, that is 10 square 100. So we got as 500 minus 250, that is 250 feet. Okay, so the question is distance traveled in 30 seconds. So the first 10 seconds it is 250 feet. Okay, then from 10 to 20 seconds it is 500 feet. From 20 to 30 it is again 250. So total distance traveled equals 1000 feet. Okay, total distance traveled in a is 1000 feet. The one more question is there. Draw the position time graph. Okay, so we will draw the position time graph. So this is time in the x-axis and position in feet. Okay, position in the y-axis. So we know that at 10 seconds distance covered is 250. Okay, 250 feet at 10 seconds. But what's the curve actually here? It's a curve. The shape of the curve is like this. Why? During from 0 to 10 seconds, acceleration is constant. So that is velocity is increasing. Velocity is increasing means the slope is also increasing. So from you can see from this curve, at each point the slope is increasing. So it's the curve. It's the distance curve from 0 to 10 seconds. From 10 seconds to 20 seconds, at 20 seconds, what is the total distance covered? That is 250 plus 500, that is 750. Okay, 750 at 20 seconds. From 10 to 20 seconds, acceleration is 0. That means the curve is a straight line. Okay, the graph is a straight line. At the end of 30 seconds, distance travel is 1000. Okay, at 30 seconds, distance travel is 1000. And the shape of the curve is like this. Why? Because the acceleration is negative. That means its velocity is decreasing. Look at this curve. Okay, at each point, the slope is decreasing. You know that the slope is the velocity. So this is the position time graph of this curve. Okay.